Guli 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 wacha lingango lingango guli 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 wacha 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 lingango.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iaquinta Latief.
My name is Verryl Azis Kusuma Wibowo.
My name is Muhammad Hisyam.
And today we're showing you our presentation on applications of root finding methods in real world fields. So, introduction to root finding techniques is that root finding involves determining the zeros of a function, which are the values of x for which fx equals 0. These methods are crucial when direct analytical solutions are impractical or impossible to obtain. Understanding these techniques is vital for tackling problems in diverse fields such as engineering design, computational computational physics, financial modeling, and game development in AI. So the first, projectile aiming in game physics. In game development, accurately aiming projectiles is crucial for realistic, physical, and engaging gameplay. Route finding helps determine the precise firing angle needed to hit a target. The problem: aim a projectile from an initial height, which is YO, with a given velocity to hit a target at a specific horizontal distance and height. And that's the formula. And the method, the Newton-Raphson method is ideal here due to its speed and the known analytical derivative of the function. The result, for a typical scenario, the calculated firing angle might be approximately 25.9 degrees. This application is vital for trajectory prediction, hit detection, and creating immersive game environments. Construction: analyzing cable sag, or canary. Engineers use route finding to analyze the behavior of suspended cables, like those in power lines or suspension bridges, ensuring structural integrity and safety. The problem: determine the canary parameter A for a power line for a power line with a span of 60 meters and a desired midspan sag of 2.5 meters. And there's a solution, the formula, and the method. Robust methods like bisection or secant are preferred for stability, especially when initial guesses for A might be less accurate. The result: the canary parameter A is approximately 180.4 meters, indicating a shallow sag over the span. This analysis is critical for designing safe and efficient cable-supported structures. Fero?
HVAC design, the Colebrook equation. In HVAC and fluid mechanics, calculating the friction factor for turbulent pipe flow is essential for efficient system design and energy consumption. Problem is calculating the Darcy friction factor F for turbulent flow in a pipe given its diameter d, Reynolds number Re, and roughness epsilon. The formula is Gf equals 1 per square root of f plus 2 log base 10 times epsilon per 3.7 times diameter plus 2.51 per Re times square root of f equals 0. Method is the Newton-Raphson method is commonly applied due to its rapid convergence with a good initial estimate. Result is a typical friction factor might be approximately 0.08182. The accurate friction factor calculate ensure proper duct and pipe sizing, leading to optimal energy efficiency. Next, robotics and animation, tool-link arm kinematics. Route finding is used in robotics and animation to solve inverse kinematics problem, determining joint angles required for an arm to reach a specific point. Problems is the problem is finding the joint angles theta 2 for a two-link robotic arm with given link length L1 and L2 to reach a target point X and Y. The formula is cos theta base 2 equals L1 square plus L2 square minus x squared plus y squared per 2 times L1 times L2. The method is often solved directly using the law of cosines or Newton's method for more complex scenarios with constraints. The result is for a target at 2.2 for x and 1.1 for y, the elbow angle would be approximately 88 degrees. This enables smooth, precise robot arm motion and realistic character animation. Next. Game AI, weapon DPS balancing. Game designer use route finding to balance game mechanics such as determining the necessary upgrade level for a weapon to achieve a target damage per second or DPS. Problem is to find the upgrade level X required for a weapon to reach a target DPS or T, the power of star based on a given damage model. The formula is Fx equals P times 1 plus alpha x times e power of beta x minus t power of star equals 0. The method is Newton-Raphson is highly effective as the derivative of the DPS model can often be analytically determined. Result, approximately 12 upgrade levels might be needed to reach the desired DPS. This ensures fair and engaging progression curves vital for player satisfaction in role-playing games and
Key
next Hisyam.
characteristics of route finding method. Each route finding method offers distinct advantages and trade-offs, making the choice dependent on the problem's specifics. Newton's Raphson. Known for its fast convergence when an analytic derivative is available and a good initial guess is provided. Secant method. A derivative-free alternative to Newton-Raphson, offering robustness without the need for complex derivative calculations. 3. Six-point iteration. It's simpler to implement but generally slower to converge, often used for its conceptual ease in certain problem types. 4. Bisection method. Highly robust and guarantees convergence if a root is bracketed, though it converges linearly, making it slower than Newton-Raphson. The selection method depends on the conversion speed. Convergence? Convergence speed. Uh, Computational cost and availability of the derivative information. Next. In conclusion, uh, root finding methods are in, indispensable tools in a wide array of fields, enabling the solution of complex problems that underpin modern engineering, scientific research, and technological innovation. In gaming, it's used for realistic physics and precise trajectory calculations. In construction, it's used for structural analysis and design optimization. In robotics, it's used for controlling movement and inverse kinematics. In HVAC and fluid dynamics, it's used for designing efficient pipe and duct systems. And in AI and optimization, it's used for balancing game mechanics and complex algorithms. From the virtual battle from the virtual battlegrounds of video games to the structural integrity of real-world infrastructure, these numerical techniques are fundamental to finding solutions where analytical methods fall short. Okay, that was all from us. Thank you for your time, and we hope to present to you again.